let's get started. We need to be more careful. So for those people who don't know me, my name is Jean-Georges Perrin. I often go by JGP or JG. I've been building data platforms for the last 15 years. I am the president and co-founder of a user group called IDAUG, stands for Artificial Intelligence Data and Analytics User Group, which I'm inviting you to join. I know that some of the people in the audience are actually members. I'm also one of the few lifetime IBM champions. We are 30 in the world. I wrote the highly rated second edition of Apache Spark in Action, published by Manning. So you can follow me at JG Perrin on YouTube, on Twitter, and you'll see what I'm sharing. And I'm sharing stuff on my blogs also, at jgp.ai. So that's me. That's Spark in Action, IDAUG, which we had a great conference by day on March 14th about kind of data, AI, fun stuff. So book your 2023 date, and if you go there soon, we'll have the recording of this year actually. So let's get started and tell me how much this is relevant to you, okay? I know that when you use jokes, you should not explain them, because if you have to explain the joke, then it's not a joke anymore, right? But I've experienced that a lot in my data career, and people are kind of laughing about it, but unfortunately, it's too true to be completely not laughed about. So I'm going to talk about a little bit about Juliets Journey, and Juliet is an analyst. So part of her job is to go through mountains of data, as you can imagine, and she's got to identify business opportunity, build reports for her leadership, all these kind of things. And she needs access to trusted data to discover insights and build a strategy, right? She cannot just rely on random data. And she needs a platform to experiment. And then after experimentation, she needs to be able to productize quickly what she's been doing. So to understand a little bit about Juliet's journey, let's get back to a little bit, I would say, the basics, and go back to RDBMS. Okay, that's how data. Well, I wouldn't say that's how data started, but that's probably how far back I want to go today. So, and I'm picking up a receipt, a slip from my favorite auto parts store, and you can see here that you've got different information. If you're taking all this information in consideration, okay, you can create a relational database, and that's how you do it, right? You create tables, you create links between the tables, and that's basically how the data has been stored for, I would say, like 20-30 years, since the 80s roughly, and it's still a lot of use those days in so many MySQL, Oracle, Informix database across the world. So, but the real value when you're thinking about analytics is when you're starting to consolidate data. So when you're bringing the data together from all your different stores to be able to say, hey, this is the part that I'm selling the most. This is the customers that are the most important to me. And all this kind of nitty-bitty features, you can do that. So what we decided is, hey, okay, let's consolidate all these things and go by creating data warehouse. So it's a very powerful tools for analytics, but a little bit on the downside is that the schema you need to use is very strict. So when you're trying to onboard data in your data warehouse, it becomes a little bit complicated, okay? It's not very flexible. And as you may be aware, more and more data sources are coming, okay? You've got all this clickstream data that is coming from the web, all new data source coming from various vendors. So it makes the maintenance itself of the data warehouse pretty complex. So one thing we can think is, and you summarize that in this way, okay? So you're creating a lot of ETL, extract, transform, load, and ELT processes, extract, load, and transform, that are getting very complex. So when you look at this diagram here, what you're seeing is that we're pushing a lot of this processing on the onboarding part. If I change my schema, it's going to be very expensive because it may affect a lot of downstream programs, upstream programs here that are doing this ELT, ETL transformations. And as you can see, same thing is adding new sources makes it a lot complex. So what did we create? Well, some people had a brilliant idea of say, hey, let's do a data lake, okay? And it's much nicer than a warehouse, okay? You can relate the pictures here. And what happens is it's really easy to store. I'm just taking my data and throwing it to my data lake. It's easy to store because the schema is then defined on read. But what does that mean? Well, it means that when I'm trying to read the data from my schema, that's where the messy part starts. And I've got to find where the data is being located, where's how am I going to transfer the data, how is the data being relevant in this situation, and such different things. So what happens at the end is that in a lot of cases, your data lake becomes a data swamp. Okay, and a pretty dirty one where you've got all this data that is being a little bit being there but not being really there because we don't know what's there. So anyway, so to try to go to solve this problem, one attempt was to look at a traditional big data scenario and adding some kind of almost like a cache layer towards the end. Okay, so when you're thinking about when you're onboarding data in your scenario here, you see that you've got your raw data, okay, on the complete left-hand side. Then you onboard that, you ingest this data in a bronze zone, which is raw data, but you can also find names like staging, landing zone, bronze, or swamp. That's the kind of things that you can see in the literature. But more and more we're going towards the metal, the Olympic medals with bronze, silver, and gold. But here, so the thing is, you first onboard your data, it's stored locally, and then after that you apply all your data quality rules, all your statistical rules for imputation and stuff like that, where you get what I would call pure data or silver, or your silver zone. But you can also find names like refinery, a pond, or sandbox, or exploration zone. That's kind of almost your I would say almost your good data. But you may want to have some transformations that make it more operational or more ready for your analytics, and that's where you actually still transform the silver data in what the gold data is, or the rich data. And you can also find about similar name like production data, refined zone, lagoon, or operationalization zone, okay, which is a very if you play Scrabble and you place this one, you probably bingo there. But the gold data, this is where you can draw some information and put it into some kind of cache with a product, for example, like Data Lake, and be able to win all these operation cycles that can be doing that. And basically, this is what you may hear in a summarized version of what the lake house could be. Okay, so you see processing being done by things like Spark, the data lake, the lake itself being stored the data we're using Delta Lake, and consumers. You can have different levels of consumer based on basically what you want to do. So that's all good, but you still have some problems, right? So, and I think when I think about that, it's not only problems like, oh, it brings you opportunity. No, I think it's really real problems. You've got data quality problems. You've got data freshness. as your data is going through these different phases, your latency in the data is increasing. Okay, so your data may take several days to come from the producer of the data to where your analytics sits. You've got problems in data ownership. Who owns the data? You've got about standard metrics and measures. Okay, who owns that? Who defines them? And then you also have problem with source of truth, and we'll discuss that a little bit more. And the migration to the cloud. So it's not. I love the cloud, don't get me wrong. I think I spent more times in my career dealing with cloud and hybrid solutions using cloud than purely on-prem. The cloud is a great tool, but migration to cloud, which a lot of our Fortune 500s are doing right now, or because I don't think anyone is really purely 100% cloud ready yet. But the thing is, the migration is still an effort in progress, but you've got to have this mentality shift. And when it comes to data, it's not an easy one. So, having said all that, what is our source of truth? Okay, let's look at this diagram, which mimics this kind of retail operation you can have. You've got B2C stores, you've got pro stores, you also have data centers. They all have this data and producing all this data on orders coming in, on fulfillment and delivery slips. All this is being collected in a landing zone at the headquarters, and then let's say it goes to HQ, still in HQ, it goes to accounting, and after accounting, let's say it's going to analytics and data science. Okay, so where is my source of truth? Where is the true data representing my information? Okay, and you can. One synonym question to that is, where is the cheapest and fastest data to rebuild? Okay, where is the cheapest, easiest way in case of a disaster recovery? Or where is not my data completely altered by any other process? As you can see, it's not an easy question to answer, because the source of truth could be, in my store, okay, on my slips. That's the source of truth for my sold items. But is it the one I want to use as my source of truth? So one thing that has not been invented, and I'm kind of preaching for it, is kind of try to find the pantofel for data. This is a drug we use to get the truth out of people. So let's try to find it for data, okay? But it's not as easy, unfortunately. So one other issue is cataloging. When you're living in huge companies, okay, you don't have a data catalog easily accessible that says this data is of this type, or this data represent that, or in the context of it. Okay, you don't have the Macy's catalog of hats of 1911 there to help you find out which is the data you want to be able to use, or isn't, if it's public to your organization. So there's also a very lack of open source solution here. So that's cataloging. Governance is a little bit of a similar problem. Okay, a lot of people say that data governance is a big company problem, and I disagree. Data governance, and especially when in Europe with GDPR or CCAP in California, all this is relevant to even the smallest of the companies, and you've got to be able to put the governance in place around those data to make sure that you're not legally exposed. And I'm just mentioning GDPR and CCPA here, but it could be HIPAA in the US, or any other recommendations that you have in the world. So governance is really important, and it's often mistreated. And then shape of data. Okay, so what do I mean by shape of data? Is structured versus unstructured. Okay, my RDBMS versus my slip here, which is unstructured by nature. There's also NoSQL. Okay, you've got this NoSQL, which is really not only SQL anymore, which you can see in document stores, where it's really a bunch of JSON with a pseudo SQL interface, or even key value pairs, but a kind of a hash map at industrial scale. So that's kind of information. You also find graph data. Okay, and the graph data, which you've got your nodes on your edges, and data is really both at the node level and at the edge level. Okay, so that's also a completely different way of storing data. And just as a point, GraphQL is not a graph query language. Okay, GraphQL is something else. It's for API, but that's just because I'm seeing this mistake a lot of times, so I'm just leaving it here. And streaming. Okay, I just showed before, as we were aggregating all the data from our different stores, that why not streaming? Okay, I've got all my retail stores, thousands of them across the continent and internationally, and I can actually stream all my data to a central location versus having nightly batch. So I am reducing the time to analytics of my data, because I want everything faster, because everybody wants things faster. And text. There's a lot of data which is completely text, or images, or binaries, but it's just text. And you need specific data engine to do that. You can thinking about things like Lucene, Solr, Elasticsearch, that are storing this text and enabling you to search data in the text. So you see the shapes of data has evolved as well. Roles, okay? Roles are evolved from the time the DBA would be the only master of the data. The DBA would make offers that you couldn't refuse, and it's also the only offer you would get anyway. So things have evolved from there for example, typically a big two family, which is a scientist and the data scientist and the data engineer, and which you can think about the data engineer being really this guy developing and building processes, making sure that data is available, is reliable, that the data quality is consistent, where the data scientist is going to be more looking at what's inside the data. I would say the hidden gems, the pearls, the money around that. Okay, so and really, the data scientist needs to be able to be a storyteller and bringing all this information in a relevant story. Okay, and the tools being used by those families of people are really different, and I'm just focusing here on the engineer and the scientist. Okay, so you can see on your left side here you have traditional databases like I would say Informix, DB2, Hadoop, Redis, Elastic, Postgres, whatever that are, or even things like GitHub, that are really the tools that the data engineer is using, and versus the tools that the data scientist is using, which you can think about things like IBM Watson Studio, Databricks, SAS, R, but also things like PowerPoint or Excel, which are being used as part of the storytelling effort that the data scientist is providing. And of course, there's a lot of tools in common, but not that much. You can think about SQL, Python, Spark, of course, and Java. But that's a personal favorite. I don't think any data scientist is actually using Java, but I'm just pushing it. Okay, but there's also roles as well. Other roles like data architects, which are becoming increasingly more popular, and you've got also roles where I don't know if it's on the way in or the way out, which is, for example, the chief data officer, which is an hybrid between the CTO and the CIO in big corporations. But what's disappearing slowly is a DBA. You've got is replaced a little bit more by the data engineer. And data ops is kind of this new concept that is bringing the DevOps to data. So you've got more people doing more I would say more stuff, but also more also a little bit of wider range of tasks. Data steward and data curator, I'm putting them on the way out because it's still some things that you find, but it's not. It's more like a role associated to someone, to a business analyst, or to, and not really a title anymore. So I know it's other roles, and it might be on the way out, but the role is there, but the title is not there anymore. So you find that. But anyway, you find all this complexity, okay? And finally, well, not really finally actually, but you've got also all this modern data engineering. Back in the day, you could think that you had one database, okay? In the 90s, it was, hey, let's use Oracle. It does all the whole thing for me. It's perfect, okay? And then you've got all this relational database. But when you look at what you've got to store right now in our world, I doubt that you're only using one data store for every use cases, every workload you're doing, right? The variety of data stores you're using is impacting what you're doing. So that's part of modern data engineering, as well as big data pipelines, right? You've got to move this data. You've got to have to be conscious about this data journey from the producer to the consumer, as we saw a little bit earlier with this different zones, and that's still something part of modern data engineering. And the cloud, okay, and the cloud and understanding the difference between compute and storage, okay. So when you're on premise, you define your storage, and you're kind of limited to the physical capacity of your servers, okay. Well, yes, you can add disk, yes, you can eventually add another computer and things like that, but it's kind of still pretty limited in the scalability of your clusters and data processing power. When you're thinking about the cloud, okay, you start the same, but the thing is, things are keeping evolving, okay. So, but the cloud and the storage can also evolve in a different way than the compute, okay. So you've got the storage and you've got the compute, which is a bit of a different way when you're thinking about on-prem. So that's contributing to complexity as well. And we all want to go to the platform. I would say we're entering the platform era, where we really want to find solution where everybody can get together on a platform, okay. So you've got you're creating this architecture, this environment where software engineers can meet our data scientists, where can meet and create all these capabilities that will help you build innovations for the company. So and you know, I kind of think about we're building platforms not because they are easy, okay, but the platform is there to support the scale of the business and the evolution of this scale. It's providing data management. It's connecting and accelerating integration with third parties. It's of course needs to provide a user experience, because as you see, we've got more and more roles, but these different roles have different experience, and then your UI and UX is actually really dependent on that. And same thing, okay, you've got self-service, you've got KPIs, you've got a workflow, all that is built on top of your platform. So that's where we are, and that's where I would say that's where that's why we need the mesh. So it's like I went for 20 minutes on why we need it, because basically the summary so far is we've got more data has taken more shapes. Okay, data needs governance and higher quality than ever. Systems have become more complex, as well as the underlying data. More roles have appeared in the organization touching data. More and more legal constraints have appeared as well. And of course, we have this desire to create more reusable and self-service platform specific and not specific data pipelines from one data source to one application. So it's getting more complex. And that's why the data mesh is bringing a different perspective, an evolution of this perspective on what we need. There's 4 principles. Okay, when you're thinking about the 12-factor app, it has 12 factors, 12 principles. When you're thinking about the Agile Manifesto, it has 4 key values and 12 principles. Here, the data mesh is driven by 4 principles that completely make sense. And it's a bit of going through this 4 principle is a little bit of a I wouldn't say annoying part, but it's a bit of the theory you need to understand before we can deep dive into how to build and how we create a data mesh. I would advise that you keep a screenshot of this, at least this slide, so as we go along after, you can see how we actually fulfilling all those 4 principles. So let's get started. Domain ownership. The idea here is the ability to scale out the data within your organization. So the problem we're solving with the domain ownership is to make sure that the boundaries of the project or of the data mesh here is reasonable, is understandable. It does not involve too many people, so that you can bring something a little bit closer to the business, that you can scale the number of teams if needed by creating multiple domains. Okay, so it's really about optimizing for the continuous change, but by localizing the change to the business domain. It's about enabling the agility by cross-functional teams, okay, and synchronization without having to go to centralized bottlenecks like data governance team, for example. It's about increasing the data business truthfulness, okay, by closing the gap between the real origin of the data and where it is used for your analytical use cases. It's increasing the resiliency of analytics solutions, okay? Focusing on your domain. The second principle is a principle of data as a product. You've got to start thinking about your data as a product and not as a process. And to think in this way, you've got to think that your data has these attributes I've listed here. It must be discoverable, addressable, understandable, trustworthy, accessible, interoperable, and valuable of its own and secure. I'd like to insist a little bit on the valuable on its own. Okay, you're not building something with. You've got to think small. Your domain can be small, but it should not be too small. It should be bringing enough value on its own. Okay, and it's really about creating this data-driven culture for innovation by streamlining the experience and the discoverability of high quality data and reducing friction. You're creating resilience and you get more higher value as a result by thinking this way. Okay, you're thinking about the data as a product, as a packaged product, versus the data being a side project or a side process of your application. The next next principle is self-service. Okay, I think almost everywhere in the world, except in New Jersey, you get to a pump and you pump yourself, right? It removes friction. It reduces time to market, or actually it reduces the time you get out of the gas station, right? So here it's the same thing. It's really obvious. You want to abstract the data management complexity and reduce the cognitive load of domains by managing the end-to-end life cycle of the data product. Okay, you want to automate the governance of each of the platform. You don't want to you want to be able to mobilize a larger population of developers so they can directly embark on your data products without a complex onboarding, training, and processes. So that's really that's really strong, and the result is that everybody can access the data in the way, of course, according to rules and security, but it's really driving innovation. And finally, the last principle is, it's a mouthful. I didn't come with it, but it's federated computational governance. Okay, I call that power to the people. It's really about transferring the data governance from a central body to the domain level. Okay, so we are going back to the domain, and we say, okay, guys, you're responsible for the governance of your own data at your domain level. So it reduces the overhead of this manual synchronization between domains. It reduces this bottleneck of creating this central data governance agency. Well, you still need those guys, but it's like agile in software engineering. Instead of having a very central way of doing things, you're pushing it to the teams. Okay, so it's one way to see data governance as an agile practice. Okay. A lot of fury on this last 4 slides. I know it's tough. I know it's almost unbearable. So let's look a little bit up under the hood, and let's be a little bit more engineers than lecturer and students. So data. For how many years have you seen data represented as a cylinder? Okay, it's even so true that Oracle has built its previous headquarters south of San Francisco as a succession of those cylinders. Okay, and if you're on 101, you cannot miss it. But then the idea is maybe we're done with the cylinder, and let's look at something more French, the hexagon, so this was invented by a brilliant software engineer, a brilliant data engineer called Zhamak Dehghani. And it's not about just a shape, okay? Of course, she didn't stop at just saying it's a shape. It's a shape, but the idea behind the shape is that it offers multiple endpoints. So when you're looking at it, you're seeing this, I would say, on the horizontal line, this traditional almost data pipeline where you've got the data sources being consumed by data consumers on the right hand side, okay? And what you see at the top is control, and what you see at the bottom is observability and discovery, okay? So it's not your traditional data schema there anymore, right? It looks like, oh, you're starting to bring a lot of things together in this small hexagon. So let's look a little bit at the various things. Let's zoom in. Okay, so we've got the data sources. I'm not saying that this little hexagon, this data quantum, because that's its name, is linked to one data source. You can have many data sources that is actually going to feed your data quantum. Okay, nothing's there, nothing original. You can think that your data is being consumed in different ways, in different mode. One is the analytics data, and one could be the operational data. Okay, all that being consumed from the same quantum. You can even imagine that the operational data could be completely CRUD-like, create, read, update, and delete the data directly at this level of interface. But that's okay. You can tell me there. Well, how different is it from an ETL process where I'm just extracting data, transforming and putting it in another database somewhere, and then I can do all these things. I can do analytics. I can do operational. Well, what the data mesh and the data quantum adds is you've got control over it. Okay, you can control what's going on within the data quantum, like starting it, stopping it, changing the data pipeline in it. We'll see a little bit about that. But that's a bit technical. But you can also add observability. Is it data okay? Okay? And then it is, I would call the observability in this scenario like active metadata. Okay, when is my data has been refreshed? How fresh is my data? How accurate is my data based on my data quality rules? Okay, that's a rather new concept there, bringing it at the data level to have this metadata, but not the traditional metadata, but having this active observability of your data so that the consumer of your data quantum knows about what's going on in it. Then you've got discovery. Okay, one of the big thing here is that you've got the discovery of the data built in your quantum. So you remember this paradigm, this principle about federated governance. This is how you can enable it, because you can give your users the capacity to read what's inside the discovery. So yeah, I can hear you. You've got JDBC drivers to a database, and then I can read what the columns, what the tables are. But that goes beyond that. The discovery API here can actually tell you a lot more about what is inside my little quantum. Okay, it's not only about one table. It can be multiple data. It could be tables. It could be multiple data sets directly in my quantum. So I like to summarize that as you meet data quanti. Okay, so that's my little guy there. A little bit afraid right now about what's going to happen to him, and you see that he's got all this little arm and legs and air, and like me, he's losing it. But anyway, that's data quanti. So let's look a little bit at what's inside our data quanti. And you can see that there's a lot of things going on inside, right? Let's zoom on two parts. First is the data onboarding part, okay? When you're onboarding the data in your quantum, you're looking at the same time as observability, quality, and transformation. And that's a big difference compared to a data warehouse or a data lake. You're looking at to make sure that as the data comes in, it's of the quality you want. You inform the observability plane there about what's going on in terms of not only quality but availability of of monitoring of your data processes. And you can, of course, have the transformation. And the transformation to what? From your different data sources to an interoperable data model. Because when you do... because when you're looking at your interoperable data, okay, in this situation, you're not building the data, or you're not designing or modeling the data for just one use case or one analytics use case. You're thinking about, I would say, interoperable data that can be used in multiple use cases. Okay, so that's a reason why you're creating this ensemble of components that is creating your data quantum. And I'm sorry. And basically the idea is you create these different data quantums and then you link them together to create a mesh. Here you've got customers, and you can imagine that I've got a customer domain where I have an application which could be a self-service profile management. Like, hey, you go to any e-commerce website and you want to change your information about your addresses, all those things. That's where you would be able to do it, and that would be part of your customer's quantum. On the other hand, you can have an order management as a quantum as well, where the data is available there, but you but the order management itself is an application that uses the order's data quantum. And when you mesh all those guys, like you would be doing a join in our good old third normal form, you would be able to gain more value and create more complex applications, like, for example, a complete customer profile application used by customer support in any organization. And of course, it's here I've linked one application to one quantum, but you can imagine, of course, that it's not the case. You would have a lot of applications consuming from eventually the same quantums. So, and that's where you remember that we've got this principle of domain ownership, okay? Each quantum is a domain. And everything is based on microservices, of course. The inventor of the concept of the data mesh, Zhamak Dehghani, works for the same company as Martin Fowler ThoughtWorks, and Martin Fowler is probably the guy that invented or coined the concept of microservices. Okay, so everything is linked there, and when you're looking at all these things, you can see that you've got microservices, and the payload and the APIs that are going to be used for control, observability, and discovery, they are all the same. Okay, so now you're creating an interoperable system where you've got data, but you've got also all the metadata, all the monitoring, and all the observability accessible via the same APIs. So, going back to our principles, each quantum is a domain managed like a product. So it provides self-service capabilities through APIs, and even governance via a generic a generic dictionary API. So really, our contract, our 4 principles are validated when you're there. Okay, so if I now go back to Juliet, she's now has access to trusted data, dictionary, and she's got that all directly in her notebooks with proper governance. So Juliet is satisfied, and you're bringing home what needs to be done. Here's a few resources. That's probably also a slide you want to screenshot, but I'm happy to share it as well. There's actually 2 books available on data mesh. There's the book from Zhamak Dehghani, who coined the concept, and which is available for on Safari or by the O'Reilly, and Manning Publication is working on a data mesh in action book, which is a little bit of a different approach than the one that Zhamak is offering. So it's really good interest. It's really interesting to compare the two approaches to that. So in conclusion, what's your key takeaways? Data serves the user. Data feeds application. Data is more and more complex. Okay, it sounds basic, but that's where we are. And the cloud brings fantastic new opportunity for data by separating the storage and the processing and the compute part of it. So it really brings up the question as a takeaway of does the data need to be siloed in an organization or split or meshed? Okay, and remember, one of the most important concepts is that quantums are much happier when they mesh. So, with having said that, thank you very much, and I'm of course open for questions, comments. The good thing is that we're on Zoom, Teams. You cannot throw tomatoes at myself. You would just eat your monitor anyway. So, thank you guys.
Thank you, JG. We'll open it up for questions at this time. Feel free to drop your questions either in the chat or unmute your line and you can ask JG directly.
I did have a question, JG. Also, hello again. This is April. How do you think that newer out-of-the-box software applications are essentially coming along in the industry of data mesh, like Starburst?
So that's a very interesting question, and there's a big debate about all that within the data mesh community. When Zhamak, so it's not something coming from a vendor, right? When you're thinking, Zhamak is voting for vendor, but a service vendor, not a software vendor. And what's really interesting in this scenario is really that there's a lot of people that start to claim a little bit like Starburst that they have a solution for a data mesh, right? But the thing is, there's nothing really there. There's not even a standard about the APIs that you would think you that would be great to have. Okay. My dictionary APIs would be great to be standardized so that I could eventually start selling my data as a data mesh. So I don't know where the industry is going to be, and that's going to be an interesting evolution to see how the vendors. Okay, right now a lot of the vendors are looking at Data Fabric. Okay, one of my favorite vendor is pushing a solution based on a Data Fabric, which of course it's totally acceptable, but it's not a data mesh. Okay, you still have a lot of the problem, and I didn't even describe what a data fabric would be. You've got other companies that are pushing Lakehouse. Okay, and so it's going to be interesting to see how the market is going to react to that. It's a rather new concept. I've been talking about the data mesh with a lot of people, and not a lot of people are aware of it. So by the time it's a little bit the vendors, it's going to be interesting to see how it evolves. But right now, I would say that anyone saying it's got a data mesh solution to sell you is a liar. And I'm not saying a liar and a traitor. I don't want to make any references in news, but just a liar. And you can see some vendors who happen to have a search engine, and for example, they're recycling some other products they have and say, "Hey, this is my data mesh," because they didn't find the market for their product. So that's kind of a little bit, the fun part of some vendors trying to recycle. Hey, I've got this. Finally, I've got a market for my product, which I didn't know what to do with anyway. So it's interesting. We'll see how it evolves. I think that I think right now we should not fall in the trap of falling for data vendors. And I cannot tell you about what I'm building or not building for the companies I'm working for, but I think it's interesting to know that there's nothing out there in the market right now that fulfill this promise. A question from Robert: do the data pipeline platforms like Spark, Flink, Dataflow, etc. support data mesh yet via their SDK, perhaps? So my approach to it, and Robert, the thing is, a lot of different. It's still a very new concept, okay? To be honest, so do we have some kind of consensus? I would go back to this slide there and see that, when you're thinking about Spark, Flink, Dataflow, etc., Dataproc, and names them, okay? Where do they fit there? They mostly fit at the transformation in the box or the component I call data onboarding. So at this stage, this is where you see a lot of these players. So do they have APIs? Not yet. Do they have SDK? Not yet. But the thing is, you see they're kind of squeezed here, and I didn't go into much details about the architecture, but you can see that they are squeezed between the control plane and the observability plane. And it's really about, okay, how do I perform my transformation from my data sources to my interoperable data model, okay? And this is where you could do that with Spark, Flink, Dataflow if you wanted, right? There's no limit. I could argue that I've suggested to people to do it with Perl scripts. I'm just kidding, okay? Don't do it with Perl scripts. But you could if you wanted. Still don't do it. But anyway, so yeah, I think I hope I answer your question, Robert. But the thing is, that's where it is. A lot of the processes and a lot of the habits I'm seeing with data engineers is that they're focusing on the data pipeline, where here's the data pipeline is really embedded as part of the data onboarding process, right? You're not focusing, you're not putting the data pipeline in front of your eyes. You're putting the quantum in front of your eyes, and the data pipeline is an essential part of it, but it's still only a part of it. Question from Shreyas. How would data mesh fit in an unstructured data fit as image and audio files which data scientists use? What's my thought on that? Okay, so as going back a bit to the question with April, okay, there's no product. And you see here, even I could have represented, if I look at the internals of my data mesh, I could say something here saying, hey, data mesh, this orangey thingy big box there, it could be a database, okay? It could be. Then I could have used my cylinder, my all good cylinders there. But no, what I'm thinking here is that the data doesn't have, I don't care about the shape of the data. I don't care about the format of the data, okay? You've got to have APIs to access it. You can have the dictionary API. You can have your observability API. You've got your control APIs. But the thing is, the data itself can be anything, okay? It can be anything. It could be files stored in GitHub. It could be audio, wherever you want to store it. It could be files on S3, and it could be videos on S3. Okay. The thing is, then you're defining your APIs to consume it, like what I put on the right side here. Okay, your analytics data clients or your operational data clients, and you're providing the governance via your access, your metadata access via the APIs. Then you realize that you're completely open to any kind of data you want. It could be. So I've seen some implementation of data mesh with CSV files. Okay. I honestly am not a big fan of the idea of it, but you could distribute CSV files via a data mesh. Still, like Perl level kind of comment. Okay, don't do it. I think it's not a good idea. But whatever, some people are creative. Thank you, the Select Group, for hosting us and making that available and possible. I hope you liked it. Please feel free to contact me on LinkedIn, or if we're not already contacted, I know a few of you are. Well, thank you very much. Bye-bye. Thank you for watching this show today. My name is Jean-Georges Perrin. I often go by JGP. I build innovative data platforms at PayPal. I am the president and co-founder of ADAUG, the Artificial Intelligence Data and Analytics Users Group. I am also one of the few lifetime IBM champions. I wrote the highly rated second edition of Apache Spark in Action, published by Manning Publication. Please follow me on Twitter and YouTube at JGPerrin. You can also read more about my opinions, my experiences, and all the things my editors didn't want to put in the book or my articles in my blog at jgp.ai. Thank you. Bye for now.